We here at GD&T Basics believe we found the sole tolerancing solution to finally close the last chapter in the designing and manufacturing of the Turbo Encabulator. The sole issue lies in the production of the highly complex Ambifacient Lunar Waneshaft, specifically ensuring the tolerances have been applied with accuracy and diligence. Let's begin a detailed walkthrough of Drawing U+1-F4-A9 Revision Tango 7. Now, I want to remind everyone, this component operates at ambient pressure in a non-load-bearing environment, so obviously we're assuming integrated core tolerancing across the board. First, you'll see the central anti-fatigue stress amplifier that has a position tolerance relative to the modal true position at MMC in correlation to datums A, B, and omega. As a note, we've started using Greek letters on the tertiary datum references within the feature control frame for European standard conformance and vibes. You'll also see that this statistically fluctuating feature is constrained in position of 1.5 thou, but with a bonus profile of aligned tolerance applied only during the waning phases of the lunar calendar. This was critical for aligning with our cross-functional synergy protocols in the semi-rare fluctuating states of allowed bonus spin. Now, feature 47 beta has a concentricity tolerance virtually relative to a datum that was removed 2 revisions ago. We've left it in per the direction of the standard as sort of a spiritual guide. It's also back annotated to a feature that doesn't exist in 3-dimensional space, but does, however, show up in the optionally explicit exploded views. This obviously is textbook usage of a metadatum defined in the ASTM MYTH42. Next, take a look at this linear spline, which was reverse modeled from the pressure signatures of the 6 hydrocoptic Marsal vanes. These features employ the profile of a surface tolerance constraint, but only in the Z' direction. The Z' axis, of course, is defined by the flux map located on the 5th page of the supplemental math addendum. Clearly, it needs not be stated, the hemispherical nesting socket must maintain a cylindricity of 0.5 micron to ensure proper alignment with the thermal flux compensator, which is in early phases of geometric consideration. This feature here, a modified recursive undercut spiral, has a compound angularity tolerance of 0.002 of a universal degree relative to the harmonically driven datum structure, which itself is derived from the angle of capacitive directions. In layman's terms, that's the angle at which the part naturally rolls off the table during inspection. All other angles are held to the unspecified tolerances indicated within the title block. Speaking of quality assurance, per a QA request, we've added a flatness callout to this radial surface. I know that's technically and morally meaningless, but if you look closely, it makes the drawing feel more confident. This chamfer has a circular runout of 0.2 of a thou, but only during clockwise rotation under 7 RPM. However, above 7 RPM, obviously it self-corrects via quantum tolerance shifting. We have also implemented the CYA protocols and applied formal profile controls to all surfaces relative to the optionally mandated datum scheme. Now, you may notice the datum reference frames contained in this drawing form a non-Euclidean loop, and if you follow the callouts in order, you'll eventually end up back at the first feature, but rotated 180 degrees on the imaginary axis. We call this the Mobius tolerancing strategy. Lastly, this part is made of cryogenically stabilized flexibronze that is plated with electrosincere nickel and heat-treated to roughly the hardness of a non-Newtonian fluid. We know most inspectors have a desirability bias towards measurable components and are wondering if this part can even be inspected, and technically no. That's why we've identified each critical dimension with a TBD designation to reduce unscheduled high-velocity close contact discussions. Additionally, to account for this, we've also rolled out a new measurement methodology involving laser interferometry, calibrated random sinusoidal data collection, and data-driven wishful thinking. Early results are inconclusive but very positive. We expect about 60 to 80% compliance, and the rest is covered by the functionally acceptable chaos clause in the ASTM MYTH42. Now, there's a lot of tolerances we haven't covered here, but just remember, tolerances are really just tiny hopes and dreams. Thank you for your time. Feel free to leave a comment, as your feedback is merely a formality to confirm your astonishment with this engineering breakthrough.